right? Can you guys hear this? You can hear that, right?
Yeah.
Okay, good.
Stories like these emphasize how important it is to understand what causes cancer.
Research over the past 30 years has led to the discovery of exactly what causes cancers.
Mutations cause cancers. But what causes these mutations? 3 factors are responsible. First, random errors occur every time a cell divides and copies its DNA to make 2 new cells. This routine process happens millions of times every day in everyone's body and usually does no harm. However, cancers can occur when such errors, simply through bad luck, affect an important gene rather than an unimportant gene. Our research suggests that nearly 2/3 of the mutations that cause cancer are due to these errors, this sort of bad luck. The second factor is environmental. Some people add to the number of mutations in their bodies by their behavior, such as sunbathing or smoking. The third factor is inherited. Some people are born with mutations that make them more likely to get cancer.
Let's use the analogy of typing using a keyboard. Because we are humans, the task of typing will of course result in typos. This is just like mutations that occur when normal cells divide. Behavior, such as typing while tired or when distracted, can cause even more typos, just as certain behaviors can cause extra mutations in DNA. A factory defect in the keyboard, like a stuck key or a missing key, can cause even more typos, just like an inherited factor can cause more mutations in DNA.
Let's look at pancreatic cancers as an important example of these principles. About 3/4 of the mutations that cause pancreatic cancers are due to errors made during the division of normal pancreas cells, that is, bad luck. About 20% of these mutations are due to environmental factors such as smoking, and the remaining 5% of the mutations that cause pancreatic cancer are inherited. Our research suggests that nearly 2/3 of the mutations that cause cancer are due to these errors, this sort of bad luck. Everyone should avoid behaviors that increase the chance that they'll get the mutations that cause cancers. But many people will develop cancer no matter how perfect their behaviors are. These people should certainly not feel guilty about getting the disease. There is nothing they could have done to avoid it. Because some cancers are inevitable, we believe that more research to find ways to detect cancers earlier while they're still curable is urgently needed.
Okay, you guys all still there? Yeah? Okay. No, right? I was getting like these messages though. Was it someone? Oh, who is this? Oh, Lidu, are you there now? Is he back? Yeah, Lidu, are you there?
He's muted and his camera's turned off, or he's just not here. I don't know.
Says that he's here. No, right next to him.
Yeah, I see him.
I guess he's just muted with his camera off.
No, I think he just. Because look at this, it's taken from the call. That laugh, I'm sorry.
I just feel like there's something always up with his Wi-Fi.
Your screen is frozen on my screen.
All right. Well, let's. I don't think we can wait for him. Oh, he just disappeared now, right? Lidu's not there anymore, right? No, yeah, he's not there. I don't know. Say, I think we should move. I think we need to move on. But if he needs to catch up on some stuff, I can just like meet with him separately, okay? Or maybe one of you guys could help. God. Yep, trying. Okay. All right. Anyway, all right. We're gonna proceed. Are you guys okay with that? All right. So we're doing this. We're playing King of Slide. Okay. Intro video. Okay. So what is cancer? So cancer is caused by a mutation in the genes, right? That leads to, and it can be a gene mutation or a chromosomal mutation, but it leads to uncontrolled cell growth, cell division, and essentially a cluster of cells that are dividing rapidly is called a tumor, right? This is all pretty common knowledge, right? And based on the video, what did they say the three causes are?
Inherited, environmental, and like errors in DNA replication.
Exactly. And which was the most common?
DNA replication.
Mm-hmm. Okay. And then what was the second most common, or the most the largest factor?
Environmental.
Environmental, or your habits, lifestyle, and then the final one was just inherent DNA. Good. A random copying errors was the first one. Environmentals was the second, and in genetic mutations that are inherited, because all of them essentially are gene mutations, right? But it's a genetic thing that maybe your parents had a mutated gene that then got passed on to you that is then more prone to getting cancer. Okay? Do you guys remember the cell cycle? We talked about this when we talked about, and we're going to talk about this again when we talk more about mitosis and meiosis. But the cell cycle, do you guys remember that it looks kind of like this, right? What happens during the S phase? Do you guys remember? What does S stand for?
Secondary?
Not. Synthesis. Yes. That's when DNA replication occurs, right? So basically, every cell goes through this cycle, right? So let's say, let's start right here, and you could start at any point, because again, it's a cycle. But basically, mitosis is when one parent cell divides into two new daughter cells, right? And then, so let's say that this is where a new daughter cell is born, basically, right? The first phase, this is called gap 1, and it's a period of growth, and then the cell's just starting to carry out its normal functions, right? So if it's a cell that's responsible for producing insulin, it's probably growing and also, transcribing the DNA that's responsible for its job, which is to produce insulin, right? And then after a certain point when it's growing and doing its functions, then it needs to start to prepare to divide into more cells, right? So this is where it does that whole process of DNA replication. So again, you guys know that process really, really well, but it happens right here, right? During the S phase, which stands for synthesis, right? And then after that, then now it's a huge cell that has twice as much DNA as it normally would. It still undergoes a little more growth and a little more functioning. It's still doing its job or whatever. And then it starts to prepare itself to then divide that double DNA in mitosis and then carry on the cycle by making two more cells, and so on, right? Okay, so basically, can a cell just keep dividing and dividing and dividing? Do we want the cell to always be dividing no matter what? Suppose it's like a car almost. We want the car to just drive around without any sort of controls on it at all.
No.
No, right? So what we have in the cell cycle, and these are our genetic, they're genes that are basically responsible for this, is that there are these various checkpoints along the way, here. I think there might be one up here too, but they're basically these points where if the cell doesn't pass certain requirements, suppose the environment isn't giving it enough nutrients, right? You don't want a malnutrition cell to go ahead and divide and whatever damage that it has, it's going to pass on to the other children cells, right? So basically, there are all these evolved mechanisms to stop DNA from actually, or to stop the cell from dividing up here, right? So those are good things, right? That's good to not have something just going out of control, right? Do we agree on that? Yeah? So, but basically, cancer is what happens when one of these, like this one, when the things that are stopping this cell cycle from, in other words, they're regulating the cell cycle, right? They don't just let it go out of control, they're regulating it, right? But when these but what determines these regulators? Genes are responsible for making, so suppose this is a protein that kind of stops the cell from replicating, right? What happens if there's a mutation in the gene that encodes for this protein? Is that protein going to work?
No.
No, so then what's going to happen? This would basically not work, so it wouldn't be able to stop the cell cycle, and then the cell cycle could just keep going around and around and around, and that's when the cell starts to grow uncontrollably, right? So these stop signs are checkpoints, and basically they are called, like, those are the mechanisms that the cell has to regulate the cell cycle. All right? So one of those genes that's responsible for regulating the cell cycle is called a proto-oncogene. And proto-oncogenes are, we need them, right? Do we need our cells to divide or no? Yeah, so we're constantly, I mean, even though we're not, some of us aren't growing anymore, even after you stop growing, you still have like all these, you're shedding skin cells all the time, you're getting hurt, and then you need to regenerate cells all the time, right? So you do need cells that are going to help you replace the cells that are getting, like shed and stuff like that, right? So one of the genes that's responsible for making proteins to help the cells stimulate the cell cycle, so that that's going to force them or cause them to go ahead and divide, those are called proto-oncogenes, right? So these are good because they code for products. So remember, genes code for proteins. So the proto-oncogenes, they get transcribed, and then they make these proteins that basically in the cell cycle, they stimulate the cell cycle, right? So think about the car again, right? So suppose we have this car. What do we need to make the car go?
Yes.
Gas. Let's say that like proto-oncogenes sort of like so they make something that actually helps the car go, right? So it's like something that's positive that they need to put in order to get the thing to go, right? And usually in a non-dividing cell, those proto-oncogenes, would we want so much extra gas in a car that's not going to go, that we don't want to be driving anyway? Would we put a lot of gas into that? No, right? So basically, proto-oncogenes are really good for cells that are dividing, that need to be replenished, that need this extra gas to help the cell cycle go. But typically, like once you're an adult, and if there are certain cells that should not be dividing, these proto-oncogenes should be turned off. They should be relatively inactive. They shouldn't have like a lot of the proteins, because otherwise those might give too much gas and make the car overactive, right? But so what do you think happens with cancer, though?
There is no
It's always active.
There's too many.
Too many. So it's not that there are too many, but then they become overactive, right? We turn them on, and there are different ways to turn on those proto-oncogenes. So basically, when a proto-oncogene mutates, it becomes an oncogene, right? And the oncogene is the bad one. So proto-oncogenes are ones that we need for normal like cell growth and cell division. But once that proto-oncogene turns into an oncogene, then that basically is turned on all the time. Or the products that are being made from the normal proto-oncogene are way over-made. So it's like pumping way too much gas into the car when it only needs like a certain amount of gas, right? And then the car is just going to go on and on forever, and it's never going to stop because there's all this excess gas in it, right? So this is a bad thing because then the cancer is going to build up, right? Then the cell is just going to be overstimulated because it has all these little proteins that are like telling it to keep dividing. So then we're going to end up with a tumor, right? So you see how this is like a positive regulation of it, like because we're actually forcing the cell cycle to go, right? So suppose I have a car. What's another way of, so another way that I could stop the car, I could get the car going is to get rid of something that was blocking it, right? So it's like, this is called negative control. So let me explain what I'm talking about. So there are these other genes. So you guys see how these are the same thing, but this is the mutated version, right? So this is the normal thing that makes proteins that cause cells to divide. But when that becomes overactive, when these become overactive, they become oncogenes, and then they just make too much of those proteins, and then the cell is always dividing. Right? The other one, this is the opposite. It's like a tumor suppressor gene. So do you think this is a good thing or a bad thing? If it suppresses tumor.
Good thing.
That's a good thing, right? Good. So we want these, because these genes, again, genes create mRNA that create proteins. So it codes for products or proteins, right, that actually inhibit the cell cycle or stopped it. These are the ones that kind of like give those checkpoints that are like, no, don't divide anymore, right? So these are good things. We want these to be functional, right? Because we want those proteins to have the right shape, the right amino acids, so that they're going to stop the cell from dividing uncontrollably, right? Or when it doesn't need to be dividing, right? What do you think happens when these get mutated? Can they make these products that are going to inhibit cell division? So once we have mutated tumor suppressor genes, basically they can no longer inhibit cell division. So that means that what happens? If they can't inhibit, which is kind of like a double negative, what effect does that definitely have on the cell cycle then? If you can't stop something anymore, that means it's just gonna go uncontrollably, right? Good. So these are two different types of genes that are implicated in cancer. So again, think about like the different controls of it. This is one that's actually like causing it by pushing it, and this is one that's causing it by not stopping it. Do you see the difference? Yeah? Okay. So P53, the letter P stands for protein, right? So what causes a protein to be made? Where does a protein come from? What was the original like sort of design that kind of helped that protein come into being? Where do proteins come from? Central
DNA.
Good. So DNA. So proteins come from DNA, right? So that means it comes from a gene, right? So P53 is basically a protein, but it's created from a tumor suppressor gene. Okay, so a tumor suppressor gene creates this protein product, which is called P53. But sometimes the gene itself is also called P53 because it makes that protein. But make sure you know that P53 is the actual protein. And then if we're talking about the gene that makes P53 is a tumor suppressor gene. So basically, a tumor suppressor gene, like we said before, leads to proteins, so P53, that inhibit cell division. So P53 is one of those regulator proteins that stops cell division, right? And do we say that's a good thing or a bad thing? It's a good thing because we want to control it so it's not just like running out of control. Okay. But P53 also has these other great properties. So it can also promote repair of DNA, which is good because, or damaged cells, right? It can help repair things that are broken, so it can detect things that are broken and then kind of like try to fix them. But are all problems in DNA fixable? Sometimes the DNA is just going to be damaged beyond repair. And then, so once something is like way damaged beyond repair, what is like sort of like the kind thing to do to it?
Kill.
Yes. So it's kind of like putting it out of its misery, right? If you see this DNA that you're just like, wow, there's no hope for you, I'm just going to kind of put you out of your misery. That's pretty much what P53 does. So P53, not only does it create not only does it stop the cell cycle from happening or from going out of control, it also helps repair DNA that is repairable. But then, if it's too long gone, it will actually initiate this process called apoptosis, which means it tells the cell to commit suicide, basically. Which sounds really ruthless, right? But it's actually really good, because then that cell will just not go and damage the rest of the cells around it, and it will just kind of, it's lived its life. It needs to kind of, be euthanized, right? So basically the cell just gets damaged, right? But these are all, do you guys notice how these are all really crucial functions in a normal functioning person, so that the cells won't just divide out of control. They'll be fixed so that their DNA is actually working and functional, and the ones that are damaged, we'll just get rid of those to maintain a healthy population of cells, right? So these are all really, really crucial responsibilities of p53. What do you think happens in cancer?
It's mutated.
Yes. So what would a mutation in the gene that codes for p53 result in? Would it inhibit cell division anymore?
No.
No. Would it promote repair of DNA?
No.
So we'd have all this damaged DNA out there, and would it tell the cells that are damaged to commit cell death? No. So we'd have all these sick cells that are just dividing out of control with all this messed up DNA. So p53 is a huge, the mutation in the p53 tumor suppressor gene is a major reason that cancers occur. So you need to recognize the role of p53. The normal role of p53 is really, really important in the cell, but once there's a mutation in p53, we're kind of in trouble. All right? Are you guys all with me still? Haven't lost anyone yet. Okay. All right, so now I want you guys to watch this other video, and it's I think if I had showed you in the beginning of class, it would have been maybe overwhelming. But this other video, I think this guy also is really good at explaining things. So try to follow along. I think it's pretty clear. And at the end of the worksheet, so I'm going to give you the worksheet as soon as Google Classroom lets me post it. Then at the end of the worksheet, I want you guys, the questions at the end of the worksheet, maybe the last 3 or something, are all related to that video. So if you're looking for the answers and they're not in the notes, they should be in that video. So I really want you guys to look out for the molecular mechanisms for how these genes are being mutated, right? Okay, ready? Yeah? Okay.
Hey, it's Professor Dave. Let's talk about cancer.
He knows a lot about the science of Professor Dave Explains.
Cancer. It's the ultimate expiration date for biological organisms. Any person that were to live long enough and avoid all other health issues would eventually get some form of cancer or another. But what is cancer, and why are there so many varieties? Will there ever be a cure for cancer? Now that we understand the basics of biochemistry, we are ready to investigate this topic in considerable depth. In the briefest description possible, cancer involves cells that are dividing out of control. We need our cells to divide at a certain rate to replace dead cells as they occur. But this process is highly regulated, so we must understand that any form of cancer necessarily involves a genetic mutation that leads to errors in these regulatory mechanisms. If just one of the proteins that are critical in regulating cell division and cell death becomes incapable of doing its job, even in just a single cell, this can result in the formation of a tumor, which is a cluster of cells that are dividing out of control. We learned about how DNA can become mutated, either through spontaneous error during replication or by external factors like UV radiation or carcinogens. Again, mutations that occur outside of any gene are extremely unlikely to have an impact on the organism. But if such a mutation occurs within a proto-oncogene, which is a gene that codes for proteins that stimulate routine cell growth and division, it can become an oncogene, which is a cancer-causing gene. This can occur in a few different ways. If the gene is accidentally translocated to a new part of the chromosome where it is adjacent to a particularly active promoter, the gene might be expressed much more frequently than normal, leading to excessive amounts of that protein.
Tell me, is that what kind of is that a chromosome mutation or is it a gene mutation?
What you said is a chromosomal mutation.
Yes, right? Because it's translocation, right? So it's not affecting just like one base or like a few bases. It's like a whole chunk that gets kind of like replaced right after the promoter. What's a promoter again? Can someone tell me what the promoter is? Promoter is a section of DNA or RNA? Promoter. So you guys, you're thinking of a primer maybe? But a promoter is a section on the original, what?
DNA that doesn't code for anything, right?
No, that's an intron.
Wait, and that's an intron.
Have you guys been studying this every night? Apparently not so much. What's the promoter the equivalent to, essentially? You guys really need to get these terms straight so you don't mix up like promoter and primer, right? You need to know what it's made of. A promoter is a segment on the original DNA strand where RNA polymerase binds and it initiates transcription. Do you guys remember that? So a promoter is made of DNA, right? And then, so RNA polymerase is going to bind right here, right? And then it's going to transcribe whatever comes after this, right? So what they're saying is that this, if a proto-oncogene that's making, what does a proto-oncogene make again? It makes proteins that do what? What's the overall effect of a proto-oncogene?
Basically stop cell mutations to replicate, so cell replication and apoptosis.
No, that's P53. Proto-oncogene. A proto-oncogene is one that the products actually stimulate cell division, right? So suppose this promoter is an active promoter. So like the RNA polymerase comes to it a lot and then transcribes a lot of stuff here, right? Suppose this is something that we need a lot of. So it's always transcribing. But instead of transcribing what it's supposed to transcribe, this proto-oncogene gets translocated here, and then this promoter suddenly starts making all the stuff that the proto-oncogenes are making. What do the proto-oncogenes make usually? They make proteins that do what? Stimulate cell division, right? So then what's going to happen? We're going to get all these proteins that are stimulating cell division, and then what's going to happen? The cells are going to divide because they have all this like gas in them, right? This gas, like for the car analogy, right? And then we're just going to get uncontrolled growth, right? So this is one way that can happen. You guys need to know what a promoter is. That needs to be a little quicker, right? I'm not so confident that you guys know what that is. All right, so a promoter is it's basically like the origin of transcription. You could call it the origin of transcription if you wanted to kind of make it parallel to the origin of replication for DNA replication. But the origin of transcription, the promoter is a segment of DNA, not RNA, right? Okay, we're going to continue. Are you guys following me? Yeah?
The gene might be amplified, resulting in many copies of the gene, which also results in excessive amounts of that protein. Or there could be a point mutation, a change in a single base pair, either in the promoter for the gene, which could again lead to overexpression, or within the gene itself, which may result in a mutated form of the protein that has enhanced activity, or is more resistant to degradation, and thus operates more effectively than normal. Any of these mutations may lead to abnormal stimulation of the cell cycle. As it happens, nature has evolved tumor suppressor genes, which code for proteins that suppress uncontrolled cell growth. If there is a mutation in one of these genes that renders the resulting protein incapable of its function, an important mechanism for suppressing tumor growth can be lost. almost certainly the most important tumor suppressor gene is called P53. The protein this gene codes for is able to activate several other genes, whose proteins are responsible for a variety of activities that halt the cell cycle, typically by binding to certain enzymes and disrupting their activity. The P53 protein can also turn on genes that are involved in DNA repair, and if the DNA is damaged beyond repair, P53 can even activate suicide genes that bring about apoptosis, which is programmed cell death. This ensures that the faulty cell does not proliferate and become a tumor. So as you can imagine, any mutation within the P53 gene itself that results in a non-functioning P53 protein will be disastrous for a cell, because so many of the safety mechanisms that guard against cancer will be knocked out. Beyond this, we learned about many of the different DNA repair enzymes that are constantly scanning for the various types of mutations that can occur. If there is a mutation in one of the genes that codes for these repair enzymes, a particular type of DNA damage will suddenly become much more likely to be incorporated into the genetic code, and with no enzyme there to fix it. So there are many types of cancer that happen this way. It is quite unlikely that a single mutation will result in cancer, but an accumulation of mutations over time makes cancer more and more likely, which is why the risk for cancer increases dramatically in old age. We know a lot about cancer, but there is so much left to learn. Studies on cell signaling pathways will continue, and there is hope within the naive optimist, such as myself, that we will eventually eradicate all forms of cancer, as well as every other disease, through the intimate understanding of how to combat them on the molecular level. Thanks for watching, guys.
All right. Did you guys follow that or no? How are you guys doing? Good? Yes? All right, so if I ask you all questions real quick, you'll be able to answer them like pretty well? Yeah? So you guys understand what are the protein products of a tumor suppressor gene? So a tumor suppressor gene creates proteins, and what do those proteins do? What are they responsible for?
Inhibiting cell division.
Inhibiting cell division, right? And so if I mutate the tumor suppressor gene, right, so that the protein, suppose I do like a missense mutation, right, and the protein that's supposed to be made, that protein is supposed to then go and latch onto something and prevent cell division. Suppose that protein now is like all like, shriveled up or something, and like it can't bend and fold on itself. Then what's going to happen to the overall process of like regulating that cell cycle? Is it going to be able?
It won't work.
It won't work. So the cell will just go like uncontrolled, right? Unchecked, right? What about a proto-oncogene? A proto-oncogene, the protein product. So a proto-oncogene is transcribed into an oncogene, right? Into a protein, and that protein product does what? What is it responsible for?
Stimulates cell division.
Stimulating cell division, right? Because you need some cells to be stimulated to divide sometimes because we need to replace our cells. But suppose there's a mutation. What were the 4 ways that Professor Dave explained that a proto-oncogene could become a mutated oncogene and become overly active? There's 4 molecular mechanisms that he mentioned. Can I have one? Jasmine?
Translocation
Translocation of what?
of the gene.
Of the gene to where? Somewhere that's close to what? So if that proto-oncogene that's normally maybe supposed to be transcribed like once, a day or something, right? Suppose suddenly that proto-oncogene gets translocated, so it switched place with like another gene, and now suddenly the promoter next to it is being transcribed like 10 times a day, right? So if the proto-oncogene is translocated to an active promoter, that's one way that it could become an oncogene, right? An oncogene means a mutated proto-oncogene. What's another way that you can get that proto-oncogene to be like transcribed way too much? And it was another type of chromosomal another type of chromosomal mutation. Let's see, who should I con? Ro, what do you think? So it was another chromosomal mutation, like not translocation of the proto-oncogene, but that proto-oncogene. What could I do to that proto-oncogene to make it produce its products like way more than normal?
Radiation? Was that one of them?
Radiation can cause a mutation in it, and that can cause cancer, surely. But I'm looking for more of like a molecular basis of how that's happening. So how can that happen? I think Olivia, are you volunteering? Can't hear you. Still can't hear you. It's not working. Can you type it?
I think she typed it.
Yeah. Gene amplification, exactly. What is gene amplification? So in talking about the chromosomal mutations, so remember there was insertion, there was translocation. What's the amplification one? What's the equivalent of the amplification one? What do you think? We do. Go ahead.
Doesn't it like have more than one of that?
Of that proto.
Part?
Good. So what's that called? When you have the same thing but twice, or three times.
Like duplication.
Duplication, or I guess it could be triplification or whatever. Like, but yeah, you have multiple copies of that gene, like by mistake, right? So then that's the other way that you could then force a proto-oncogene to become an oncogene, right? What were the two other ways? And these are more on like point mutations at the base level. See, Hannah, any idea? Hannah? Any idea?
I don't really know.
You don't know? Okay. Arnav?
Not really. I don't have any idea.
Point mutations.
Point mutations where? There are two options where the point mutations could occur. It could occur in the...
I don't remember the
Promoter.
exact locations.
In the promoter. Who said that?
Hello.
Arsh, okay, thank you. So it can occur in the promoter, making that promoter extra Extra active, right? Or the mutation could occur where else? Not in the promoter, but in the
Proto-oncogene.
In the proto-oncogene itself, in the gene itself, which would somehow enhance that protein's ability to do what? What are they normally responsible for doing, the proto-oncogene proteins?
It can, wait.
They're normally responsible for doing what, Lita?
Stimulating cell division.
Right.
Cell replication.
Right. So, but if we mutate them and make them even better at stimulating cell, so suppose that mutation actually makes them more effective in doing that, right? So it's like the gas thing. If we have gas, but suddenly there's a mutation in it, and then it like makes the gas like even like more effective, then the car could like speed around the cell cycle like even more times than usual, right? So those are the four ways. I want you guys to make sure you know those four ways, right? So the proto-oncogene could be translocated next to an active promoter, right? The proto-oncogene could be duplicated, and therefore its products are going to be amplified, right? The proto-oncogene could have a mutation within its promoter itself, right, which would make it more active, or it could have a mutation in the proto-oncogene itself, which could make it more enhanced, better able to do its job of stimulating cell cycle, right? Are you guys all with me? Yes? No? Yes? Good. Okay. You guys know you have a quiz tomorrow on gene. I'm going to put a few questions on DNA replication, questions on transcription, translation, mutations, cancer. Yeah? All right. Let me just see if I can upload this.
Miss Pittman,
Yes.
could you post today's PowerPoint and yesterday's so that we can look them over? Because you didn't post yesterday's, and
Right.
I was wanting to look it over.
I forgot to do that yesterday, but when I tried to do it just now, I told you like the Google Classroom's not working, so I can't post anything right now. That's why I'm trying to do it right now. I'm going to see if it works. If not, I might have to dictate the questions on the worksheet to you. Does that sound like a good idea? No. Oh, here we go. I think it's going to let me. Maybe not. Okay, create. I'm creating material, right? Yeah, so it's working now. So I'm gonna post the mutations PowerPoint first because I want to do this all in the chronological order. So I'm gonna post the mutations PowerPoint from yesterday, and then I'm gonna post the worksheet for today. You guys, please, did I request this yet? Please, like when you're writing if you're handwriting your worksheets, can you make your handwriting like a little nicer? Because some people are like, taking notes all over the thing and it's like really hard to read. So make sure, just try to make that a little clearer if you can. Mutations. All right, I'm uploading this one. And then also when you take the picture, try to take the picture more straight. So you can, okay, let's see. All right, here's the post. Here's the mutations thing. I'm posting I'm posting the assignment, which is I would like you guys to do this by today. I'd like you to do it by today, just so we don't have these like last minute things where like everyone's emailing it to me. Can you guys try to post it by tonight? Like 12? Should I say like 12 o'clock? No one's doing it in the mornings, right? Or are you guys doing it in the mornings? No. All right, hang on a sec. Let me just go back to this. How are you guys doing, like, besides this? Are you doing Google Hangouts with all your other classes? Yeah?
I'm gonna be honest, I have no clue what I'm doing.
And some of them.
Do you guys feel like kind of like really out of touch and really like sort of lack of direction, or do you feel like you're getting more work than usual, or do you feel like it's like we're overloading you with all this stuff, or do you feel like kind of like normal?
It's less work, but I'm learning less.
Fair enough. That makes sense.
Very manageable.
Very manageable, okay. But what about your time? Like, how are you using your time? Like, so you have 4 hours in the mornings of class, and then you're basically free for the rest of the afternoon, right? Are you guys taking naps? Are you exercising? What are you doing?
It's been cold outside for like the last 4 days. It's been raining and windy here.
Raining and windy, so you've been staying in?
Yeah.
I'm
You
trying
guys
to
have all been staying in general?
Yeah.
Huh? Have you been staying in, I hope? Yeah? No. Mike, you said you were seeing your friends the other day. I hope you didn't get close to those friends.
No, I haven't gone yet, and I haven't talked to her since like Monday, so I haven't talked to her yet.
Okay. But again, you should. Is this a friend from school or a friend from like home or?
It's a friend from middle school.
From middle school? All right. Where does she live? Does she live close to you, or is it? Huh?
Middletown.
All right, Middletown. Have you guys kept up? Are you keeping up with like the numbers of the cases and stuff? Like as you're
New York City is the fastest spreading.
What is?
My mom is.
New York City had the fastest spread in the entire world, and like 200 people died in one day, so not good.
Yeah, I mean, New York is, it's not like a big surprise that that's going to spread. Like people live like practically on top of each other. I mean, well, in a lot of cities in Asia they do too, so it's not like a surprise there. But yeah, New York has like a dense population with people like all over, so naturally it would spread pretty quickly there. I was looking at the numbers in Monmouth County though, like every day they publish like what the new confirmed cases were, but like apparently at these like testing centers they like close after an hour because they've like run through all their tests. So like we're really lacking a lot of these tests. I think Marlborough, like as of yesterday, Marlborough had the highest number of cases. It was like at 29 or something. I was looking at Howell, which is where we live. That was 17, I think. My parents live in Rumson, so that was like there were 5 cases in Rumson. I think there were 10 cases in Fairhaven. Manalapan had a lot. Little Silver has like.
Manalapan has 1.
Newark is in shelter in place. What's wrong with your mic? I guess it's like just not working today.
It never works for her.
For her?
Yeah, it never works.
Okay. So yeah, you guys, I hope you're staying safe, but I hope you're not feeling, like isolated or anything, because we're all, here for you and stuff. And, to address the fact that you think you're not learning, so you guys are going to study really hard for this quiz, as if you would study for a normal quiz, right? Because even though they're only going to be, obviously, like the questions that I'm going to be able to ask are going to be fewer, because I don't, having to input them on Google forms, it's just like kind of a nightmare. It's really inefficient. And then I have to put a time limit on this quiz. I'm going to give you, I think, depends on how many questions I have, but I think, would you guys prefer like just like a half hour quiz and like 15 questions, or would you prefer a full hour quiz and 30 questions?
Full hour with 30?
Full hour.
You want a full hour, so you don't want to learn more content. You just want to review the content that you did already. You don't care?
That's what I mean, like, yeah.
Yeah, because I mean we covered a lot. We did DNA replication, mutations, cancers. It's a lot to cover.
All right, so
And
you
15 questions.
You want enough time to really like apply that, or like reflect that knowledge, reflect your understanding of that knowledge, instead of like trying to squeeze in a quiz and then like go on to something else, right? Okay. All right. So, and if you guys finish the quiz early, then we can just finish class early tomorrow, right? Because it's Friday and you guys are working hard. Okay. So, but make sure you really study tonight, all right? So that you're like really on top of what's going on. Let me post today's thing real quick before I forget. So I'm gonna put cancer PowerPoint. And the links to those videos should be on there. So if you need to go back and review those videos, I would strongly recommend it, because I think it's, I think that is really helpful. I know that they go really fast as they're talking in the videos, but if you go back and really try to understand what they're saying, then that's good. So let's see if I can you guys, whoops. Should I post, I'm going to post the cancer worksheet and the cancer PowerPoint in the same, oh no, because I want you guys to submit the cancer worksheet. Cancer PowerPoint. Alright, open. And then upload, and then I made this an assignment. Oh my gosh, I'm an idiot. Just kidding. Alright, here we go.
Did you know today's Thursday?
What?
Today's Thursday.
We didn't know that, Mike.
It doesn't feel like Thursday, it feels like Tuesday.
Well, that's a good thing then, right? That's
Today's Thursday.
My whole system's messed up since this whole online school. It feels like a weekend every day, and then today it felt like Tuesday.
Oh.
My sleep schedule got destroyed, but I mean, yeah.
All right, guys. So I want this homework by tonight, right?
I don't save homework up yet.
I'm putting it up right now. So I want it by March 26th, 11:59. You guys think you can get it to me by then?
Hopefully.
Yeah.
Possibly.
If Google Classroom is cooperating. If not, I will accept it by email as well. Hold on, I'm posting the cancer PowerPoint before you guys leave. You guys don't know anyone with coronavirus, do you? Yet?
My grandparents, they went to this adult daycare, and one of their friends there got coronavirus.
What do you think?
There's this thing where you just go there for the day and they do bingo and stuff. It's almost like a retirement home, but not really.
Okay.
A lot of people there, they were diagnosed with coronavirus, and so they've been really careful with everything.
It's really sad. I read something yesterday where people found this abandoned old folks home with dead senior citizens, but no staff available. They had just abandoned them.
Michael.
Not funny, but I can see you cracking up there. So at least very sad, right?
Yeah, I don't know why I'm laughing.
I just know, neither do I. That's all right. Who of you guys are all there? All right. So did I take attendance already, or I did, right?
Yeah, you did.
But I need to just submit it. Okay, I forgot to submit it here. Who feels like they need extra help? Does anyone feel like they need extra help in bio at this point? No? No? All right. Because if you got, as usual, during, if we were in school for real, I would probably hold lunch, sessions, and you guys obviously aren't in contact with your tutors, right? So if you feel like you need some extra help, email me, and then maybe we can schedule a time where we can do a quick hangout or something. or I can try to explain something to you by email, which, might not be that effective, but, I can try. So remember, tomorrow, I don't know how you guys are doing this whole thing with your videos and stuff, but tomorrow I want to be able to see your eyes, your desktop, to see that it's like kind of clear. I don't know how that's going to work, but do you guys you can aim your screens like down, right? So I can kind of see your...
I use my phone because my desktop camera is really bad.
You use what?
I use my phone because my desktop camera is really bad.
Alright, so how are we gonna, can you use your desktop for tomorrow though? Would that be
I can try, I can see if the camera works. Sometimes it doesn't.
I use my phone, but my desktop literally doesn't have a camera.
Oh, it doesn't? Okay, so maybe can you figure out a way to aim your phone?
I can have it
Is this fine?
I
could get this. This is the best I could do with my phone.
Yeah, I can't see your desktop or anything. But I want to make sure that you guys should probably be unmuted. I don't want I want to see that you're not typing and that you're not honestly this. Maybe I'm trying to micromanage too much, and maybe it's just not possible. So just be aware of the consequences. If you were ever to be found out to for distributing content or to other classes unauthorized, that just be aware of what the consequences would be, and this is stuff that you are going to need to know in your future lives. So if nothing else, just it's not something that you want to take a shortcut with. You want to be able to say that you learned it and understood it. So just it's on you, right? So just think about that. All right, are you guys good for today? You understand? Did you see the worksheet?
Yes.
You do everything in the morning. Oh. So should I change it back, Olivia? Should I change it back to the normal time, or it's fine? Okay. All right.
The mornings are convenient, but if changing the time is work, then I wouldn't want to put you to do,
No, I can change. I can change the time, but I want you guys to kind of do it a little earlier, so it's not last minute, and also so I can kind of check it and get it done. But I really, I think a full day is fair to give you. So if you need the full day, it's really the purpose of doing this is so I can sort of see if you guys are understanding it or not, and if not, then I can address it by our class, so we can talk about it instead of 2 days later, and then I'll be oh, by the way, you guys on that worksheet that you did 2 days ago, so it's just a little delayed if we do it that way. But really, I'm mainly checking them for completion to see that you're doing them, and a lot of you I know are doing them during class, which is fine. But yeah, try just 2 requests. Try to make it a little neater. Try to make your copies a little, a little clearer if you're taking pictures of them. And also make sure your wording is really, really precise. So for those of you who are typing it on the computer and who can't draw the pictures of what translocation looks like, or what inversion or what duplication looks like, you need to make your language then really, really precise. So I know that you know exactly what's happening in those chromosomal mutations. All right? Good? All right, guys. Have a great day. I'll see you tomorrow, and be ready for the quiz first thing. Okay?
Thank you.
Okay.
Thank you. Have a good one. Bye. Thank you. Bye.